Here's Mrs. Shopper coming back to you with measuring angles and arcs, continuing to work on circles. So here we go. First of all, the sum of the central angles in a circle is, get this, 300, I don't like it when it's that dark, 360 degrees. All right, that means if I take, and you probably have known that, when you take all of the angles in the center of the circle, it equals 360 degrees. That's going to be helpful as we move along. Okay, so when I take a look at a problem like this, I know that if I add all of these together, I'm going to get 360 degrees. Now, here's something to look at. You're probably saying, hey, we don't know this angle measurement. It doesn't tell us. Like, what do we do? What we do know is that RV is a diameter. It's a chord that goes through the center, and it cuts it in half. So actually, we can take these three values and add them all up together to get 180. So 8x minus 4 plus 13x minus 3 plus 5x plus 5 is equal to 180 degrees. So if I combine like terms, 8x and 13x is 21x, plus 5 is 26x. Then negative 4 minus 3 is negative 7, plus 5 is negative 2, equals 180. So then 26x equals 182. And then I'll take 182 divided by 26. And so x equals 7. So you can also use that idea to help you out too. Vertical angles are another way that you can use that to help out too if there would happen to be vertical angles in there. In this one, there aren't vertical angles because we don't have two diameters intersecting at the circle, but that would be something also to look at. With this one, find the value of x. All right, again, I have a diameter right here. And so I can say that all three of those equal 180. So 75 plus 5x minus 5 plus 7x plus 2 equals 180. So 5x and 7x is 12x. 75 minus 5 is 70. Plus 2 is 77. That equals 180. So 12x is equal to 103. I think I have a mistake here on my computation. This should be 72. And so we're going to get 108. And then 108 divided by 12 is 9. There we go. So it gets you 9. Now an arc is a portion of the circle defined by two endpoints. And I know that you've heard that terminology, but again, it was in 7th grade math, so it was like 2 years ago. So we have arcs. We have a minor arc, which is less than 180 degrees. We have a major arc, which is greater than 180 degrees. And then we have a semicircle, which is exactly equal to 180 degrees. So these are some good keywords to keep in mind. Minor is less than 180 degrees. Major is more than 180 degrees. Semicircle arc or semicircle is half or equal 180 degrees. All right, so here we go. So if WC is the radius of circle C, X, Z, Y, so we start at X, go through Z, and get to Y, is that defined as a major arc, a minor arc, or a semicircle? It's actually going to be a semicircle, which means that the measure of arc X, Z, Y is equal to 180 degrees. The arc measure is in degrees. The arc measure is in degrees. All right, if WC is the radius, we want to identify, let's take this color, WZX. So W through Z to X. It's really important that you follow the order that's in there. So W through Z to X, this is going to be considered a major arc. And when I look at this, I've got a 90-degree angle and a 180-degree angle. So the measurement of arc WZX is equal to 270 degrees. And then looking at this last one, WC is the radius. Identify XW. Okay, so again, we want to follow the order that they go. And so it is considered a minor arc. And its measure, so the measurement of arc XW is 90 degrees. All right. So you want to, if you don't get anything else out of here, when you look at the arcs, you've got to go in the order in which the letters are written. Okay. Congruent arcs, they're arcs in the same congruent circles that have the same measurement. Okay. They're in the same or congruent circles and they have the same measurement. So here we go. Now, how does this all play out? This is a little bit different. We turn this into a pie chart. I know you did this in 7th grade math, but again, 2 years ago, come on, we got to refresh our memories, right? So we want to find the measure of arc KL, okay? So KL is right here. So what I'm going to do is I'm going to set up a proportion, okay? 21% out of 100% is equal to X degrees out of 360 degrees. Okay, so your arc measure matches your central angle. All right, so I can set up this proportion and solve it out. So 21 times 360 divided by 100. So the measure of arc KL is 75.6 degrees. Okay. I'm setting up a proportion because the measure of the arc is proportional to the percent that it's taking up. NJL, whew, NJ all the way to L. So again, I'm going to do the same thing. I'm going to set up my percent over 100 and figure out my degrees over 360. So the full thing is 100. I'm not counting 16. So that's going to be 84%. I could have added all of them too, but I decided to take 100 minus 9 minus 7. So if I take 84 times 360 and divide it by 100, the measure of that arc, of arc NJL, is 302.4 degrees. All right, so using that fraction percent relationship. All right, adjacent arcs. Adjacent means next to. So adjacent arcs have one angle in common and they're next to each other. Okay, so adjacent means next to each other. So remember when we had segment addition postulate and angle addition postulate? Well, now we have the arc addition postulate. Same thing, same idea, only we're applying it to arcs. So if we want to find LHI, so I start at L through H to I. I want to find that measurement. Well, I know that IM is a radius and LJ is a diameter. I know that this is a 90-degree angle, which makes this a 90-degree angle. So the measurement of arc, LHI, is 90 degrees. Let's see here. Find IJK. I start at I, go through J, get to K. Ooh. Ooh. Okay, let's take a peek. So I know that this is 90. Now I got to figure out what this is. Do you see how these HK and LJ form vertical angles? that means that these two angle measurements are the same. If angle HMI is 32, then HML needs to be 58 because together they're a right angle. That makes this angle 58 because it's vertical angles. So the measurement of arc IJK is equal to 148 degrees. And again, your central angle and your arc measurements are the exact same thing. Your central angle and your arc measurement. Now, we're getting into arc length. Arc length is the distance. It's a linear distance. It's in centimeters, inches, feet, meters, right? It is the length. It's how long it would be. It's one dimension. So when I take a look at this, the length of an arc to the circumference is equal to the ratio of the degree of the arc to 360. So similar to setting up a proportion, okay? So let's put this to use. First of all, just a couple of things. First of all, the circumference, you can use 2 pi r or 2d, or pi d, I mean, that's fine. I like the proportion setup. You do what works for you. You can also use the equation where the length is equal to the degree measure over 360 times the diameter. Pick what you want. It doesn't matter to me. So let's take a look at here. Find the length of DA. So we want to find how long this is. I'm going to say that 40 degrees is to 360 as X is to pi times diameter. So this represents the total degrees. This represents the total circumference. So I'm going to set up my proportion and I'm going to solve it out. So 40 times 3.14 times 9. And I'm going to divide by 360. So the length is going to be 3.14. Okay, 3.14 centimeters. Let's try the next one. Here we go. One more and then it's going to be work time. Find the length of DCA. So again, I like to draw it. It just helps me out. So I've got 118 over 360. Nope, that's not right. 180 plus 28 is 208. All right, so I have 180 plus 28 is 208. And then this is pi times 12 because that's the total circumference. So 208 times 3.14 times 12 divided by 360 gives me 21.77 centimeters. All right. So time for you to get started on your work. Thanks for listening. Have a fantabulous day. See you later.